So the quadratic formula. This is something that's going to come up a lot in high school mathematics. It's a very simple formula that does something super important. It helps you find the roots of a quadratic equation. I'm going to assume at this point you should already know what roots of a quadratic equation are. I have a separate video kind of discussing what they are and different ways to find them. But this video, we're just going to focus on how to use this equation, x equals negative b plus or minus square root b squared minus 4ac all over 2a, how to use this equation to actually find those roots. All right, so this is used to find roots for specifically quadratic equations. This is an example of a quadratic equation that always has to be set equal to 0 when you're finding the roots and using this formula. It's not going to work with equations that have with non-quadratic equations, like that have x to the third, x to the fourth, or any term higher than an x to the second. Okay, it's very important that you're able to get this form and that the highest exponent term is an x to the second, or whatever your variable is, t to the second, p to the second, a to the second, whatever it is. Okay, so pros and cons to using the quadratic formula. Because you can use other techniques to find roots of a quadratic, or zeros of a quadratic, sometimes they're called. So pros would be quadratic formula works in every situation. No matter what quadratic equation you're given, you can use the quadratic formula to find the roots, right? That's the major pro of it. So imagine that you have trouble memorizing certain things and you're on a test and they don't care what method you use. This is the one to memorize. This will get you the roots of any quadratic equation. The cons will always be, this is an annoying formula to memorize, right? Sometimes even I forget just like a piece of it. And it's much slower, right? Doing something by factoring, right? Solving by factoring, by AM method, AC method, something like that, is always going to be quicker. However, those might not always work. So I think the best way to start learning how to use this is just looking at some examples. So let's go through those now. So here I've decided to start off with something pretty simple. You could solve this already by doing AM method and factoring, but I want to show you what it would look like with quadratic equation, right? So first we just have to set up our formula right here. Negative b, or x equals negative b plus or minus square root b squared minus 4ac over 2a. And we're just substituting in terms into each part of this formula, right? So our a term is going to be 1, our b term is going to be 5, and our c term is going to be 6. Okay, and it's already set equal to 0. If it wasn't, if it equaled something else, we would need to bring that something else to the other side in order to get it 0. So let's just now substitute. My b term is 5, so negative b is going to be negative 5 plus or minus, and I'll talk about the plus or minus in just a second, square root b squared, so 5 squared, minus 4 times a, which is 1, times c, which is 6, all over 2 times 1. And now I simplify as much as I can. I start combining stuff. So this negative 5 will just stay as negative 5 for now, plus or minus. So this will be 25. 25 minus, let's see, 4 times 1 times 6 is 24. So 25 minus 24 is just 1, all over 2. Did I do something off? Yeah, no, all over 2. Right? So now we have this kind of thing here, this plus or minus. What this means is we need to split up this into two different equations, two different situations. And this is kind of, it's a bit too much to go into now, but it's like a rule with radicals. So we need to do negative 5 plus square root of 1, which is just 1, plus 1 over 2. And we need to do negative 5 minus 1 over 2. And we'll get two different answers for this, and both of those will be our answer. So negative 5 plus 1 is negative 4. Negative 4 divided by 2 gets us negative 2. So we have x equals negative 2 as one of our answers. Here we have negative 5 minus 1, which is going to be negative 6. Negative 6 divided by 2 should be negative 3. So x equals negative 3 would be our other answer. All right. Now these next examples are going to start to seem very repetitive because they are. It's simply we're taking this equation, putting in these numbers, and then following these steps, splitting it up into two different cases, and getting two separate answers. And I'd like to use this as a first example because you can even use factoring to find the roots, and you'll find that you get the same answers. And this is an example of where if you knew factoring, this would be a lot quicker, right? Just to kind of demonstrate, find something that adds to 5, multiplies to 6, right? Well, that's 2 and 3. So we have over here x plus 2, x plus 3, that equals 0. And then mini equations, and you get x is equal to negative 2, x is equal to negative 3, right? So again, that just demonstrates the pros and cons. This works in every situation, but if you're familiar with other techniques and you see a situation where they can definitely work, factoring is much quicker, much easier, saves you a lot of time. And a lot of times that can matter on an exam. All right, let's look at the next problem. All right, so our next example, x squared plus 3x minus 14 is equal to 0. I suggest pausing the video and trying this out on your own. So if you just take a quick look at this, this is something I don't immediately think I can factor, right? I can't think of anything that can add to 3 and then also multiplies to negative 14, right? So this isn't a situation where using quadratic formula would be like, I think the only thing you're able to do. So let's just start. First, I'm going to just write the actual formula and then substitute, right? So x equals negative b plus or minus square root b squared minus 4ac over 2a. Now let's sub in our actual terms. My negative b is going to be this 3 over here, so negative 3 plus or minus square root of b squared. So I'm going to do 3 squared minus 4 times a, which is 1, times c, which is negative 14, right? So those signs are important. Make sure those go in with your actual equation. And that's all over 2a, or 2 times 1. Now let's start to simplify and condense, okay? So we have negative 3 here, plus or minus, let's see what this square root would become. 3 squared would become 9, all right? Minus 4 times 1 times negative 14 would be negative 56. So 9 minus negative 56, which would become positive 65. So I'll write that in our next step. And then 2 times 1 is just 2. So now we have 3, or negative 3, sorry, plus or minus square root of 65 all over 2. And 65 doesn't have a square root, right? I can't really reduce that. I can't actually compute it, so I would leave it in terms of a square root, okay? Yeah, and I can't actually reduce the radical either. So this would be your final answer, or depending on maybe the way your teacher wants it, or maybe you're working on a specific multiple choice question, you would actually have two different answers. One answer would be -3, right? It's that two different situations we talked about. -3 plus rad 65 over 2. And x would equal -3 minus rad 65 over 2. And those would be your final answers. If it was like a free response thing, personally, I would accept this as an answer. This is correct because this shows, like, this symbol means I have these two situations, but that varies from teacher to teacher. Also, I'm not an actual teacher, so this might be like required. All right, so this next example looks a little bit different than the last two. In our previous examples, our equations were set equal to 0, which is what we needed. Here, it isn't. So what do? The first step before actually implementing our quadratic formula would be to make sure our quadratic actually equals 0. So I'm going to just bring this 10 over to the other side, right? Plus 10 here. That cancels. Plus 10 here. What am I left with? On this side, it's going to be 2x squared minus 7x, and then minus 3. And that's all going to equal 0. Now I can use the quadratic formula. So let's take a look. X is equal to negative b plus or minus square root b squared minus 4ac all over 2a. Now let's substitute in our values. So negative b, that's that -7. So negative of -7 would become positive 7 plus or minus square root of b squared. So that's going to be -7 squared minus 4ac. So 4 times -3 times 2. Okay? And that's going to be -24. So minus -24. And that's all over 2a. So 2 times a, in this case our a is 2. That's going to equal 4. So I'll write that in our next step, 2 times 2. Now, once we've actually subbed in our values, we can start substituting, right? And I actually just skipped this step. This is actually equal to -3 times 2 times 4. So now simplifying, we get 7 plus or minus square root of -7 squared is positive 49. Positive 49 minus -24 is positive 73. Yeah. So this is positive 73 in our radical, and in our denominator we have 4. And this would be our final answer, right? Because we can't actually simplify 73 into becoming any sort of perfect square that we can take out. So this would be our final answer, or like in our previous example, our two cases. X is either equal to 7 plus rad 73 over 4, or x is equal to 7 minus rad 73 over 4. And what this is essentially meaning, just to talk about roots, if you were to put this in for x here, or put this in for x here, the equation would equal 0. All right, so let's look at one last example. All right, so this last example is admittedly a little bit harder than our previous ones, but the steps are still going to be the same. It still hopefully should start to seem repetitive. So right now we have a bunch of stuff on both sides of the equation and we want to find roots. What we need to do is get everything to the same side, so I have 0 on one side and everything else on the other. So what I'm going to do is start moving stuff over. Now I like my lead coefficient that where is it? I prefer this a term to be positive. So that's the direction I like moving everything. See how I have a negative 3x squared here? If I move this to the other side, I would get a a positive 4x. If I moved this x to this side, I would end up with a negative 4x. So I'm going to just move all of this stuff over here and then rearrange everything. So first, I'm going to add 3x squared, cancel that out, plus 3x squared here. And what I'm left with is 4x squared. And then I'm going to move this plus 2x, that cancels, plus 2x. Now negative 2x plus 2x just gets me 0. So I don't need to write anything, right? Saying plus 0 doesn't actually mean anything. And then I do plus 6 on this side. This cancels. Plus 6 on this side. Negative 31 plus 6 is negative 25. So everything here canceled out, and I'm just left with this equation. 4x squared minus 25 equals 0. Now, this looks a little bit different than our previous stuff because we only have 2 terms, not the usual 3, right? When that happens, and you still see an x squared term there, that's still important to have. You can assume, well, you can't, it's not that we're assuming it, we know it for a fact, that the missing term is 0. So in this case, 4x squared, we're missing the bx term, and then minus 25, we know that our b is 0, because we don't see it there, right? If this were something like 4x squared plus 3x is equal to 0, well, the term we would be missing would be our c term, and we would know that c is equal to 0. So let's use that information along with our quadratic formula. So x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Now let's compute this. We're going to substitute. Negative b, well that's just negative 0, right? So that's, or 0, plus or minus square root. What's b squared? Well, that's 0 squared. 0, right? Again, our b term is 0. Minus 4 times a, which is 4. That. And times c, which is 25. All over 2a, or 2 times 4. Now we can simplify. This 0 just goes away. However, this plus or minus thing still stays there. We still need it because this plus or minus is attached to the square root, right? That goes along with it. So plus or minus square root. So 4 times 25. So the way you would be able to kind of like do this in your head, 25 times 4, that's easy to do. That's 100, right? And then 100 times 4, also easy to do. That's also, this is my mistake. This should be negative 25, right? The signs need to go along with it. If I didn't put that, I would get the wrong answer. So this is negative 25. So negative 25 times 4 is negative 100. Negative 100 times 4 is negative 400. So this equals 0 minus negative 400, which gets me positive 400. and that's all over 8. Okay? Now, positive 400, that's a perfect square. We can actually go forward with this. 2 different situations, right? So what's the square root of 400? It's 20. So we're going to do first x equals positive 20 over 8, which simplifies to being 5 over 2. And we have x equals negative 20 over 8, which simplifies to negative 5 over 2. And those would be our 2 final answers. All right, so hopefully that was pretty concise. I'm hoping you're starting to understand this a little more. Just to review, quadratic formula works in every situation. It's very useful, and anytime you don't immediately see a way to factor something, and you need to find its roots, quadratic formula is the way to go. All right? All it requires you is to memorize this formula. X equals negative b plus or minus b squared minus 4ac over 2a. Well, square root b squared minus 4ac over 2a. All right? If there are any questions, leave it in the comments. If this video helped, hit the like button. And other than that, good luck, guys.